Hello, my name is Daniel, and today we will be going through the AMC 12A from the year 2006. So let's get started. First problem. Sandwiches at Joe's fast food cost $3 each and sodas cost $2 each. How many dollars will it cost to purchase 5 sandwiches and 8 sodas? Okay, so this is just 5 times 3 plus 8 times 2. That's 15 plus 16, which is 31. So this is the answer. It's A. Number 2, define x this y equals x cubed minus y. What is h, x, h, x, h? Okay, so first let's do this one. That will be h cubed minus h, and then we'll do h cubed minus that. So h cubed minus this is going to be h, right? So this is the answer. It's C. Number 3, the ratio of Mary's age to Alice's age is 3 to 5. Alice is 30 years old. How old is Mary? Okay, so since this is Alice, this is equal to something times 30, right? And then since this is multiplying by 6, right? So this is times 6. So this would be also times 6. So 3 times 6, that's 18, right? So Mary is 18 years old. It's B. Number 4, a digital watch displays hours and minutes with AM and PM. What is the largest possible sum of the digits in the display? Obviously, for the minutes, it will be something 59, right? And then for the hours, it's going to be 09, right? Because like 1, 2, that's just 3. So that's very, very much less than 9. So this is going to be the largest. So 9 plus 5 plus 9, this is going to be 23, right? So this is the answer. It's E. Number 5, Doug and Dave shared a pizza with 8 equally sized slices. Doug wanted a plain pizza, but Dave wanted anchovies on half the pizza. The cost of a plain pizza was $8, and there was an additional cost of $2 for putting anchovies on one half. Dave ate all the slices of anchovy pizza and one plain slice. Doug ate the remainder. Each of them paid for what he had eaten. How many more dollars did Dave pay than Doug? Okay, so the cost of a plain pizza was $8, but then the slices were 8 equally sized, right? And so if we have a pizza here with 8 slices, right, then each piece, and then each slice is gonna cost $1 at base, right? And then Doug wanted plain, but then Dave wanted anchovies, so on half. So there was +2 for eating anchovies on one half, right? So this is for Dave. This is the +2 half, right? So Dave ate all of these slices of anchovy pizza and one plain slice. So until this much, this is all Dave's. Dave, right? Let's write that up there. Dave. And the rest is Doug. So this much is Doug, right? So Doug paid $3, right? $3, and then Dave paid, he ate base of $5 because 5 slices, 5, and then plus half the pizza, so we have to do +2. So this is going to be equal to $7. So this difference is $4, it's D. Number 6, the 8x18 rectangle ABCD is cut into 2 congruent hexagons as shown in such a way that the 2 hexagons can be repositioned without overlap to form a square. What is Y? Okay, so for them to be repositioned without overlap, then this length and this length, they must be equal, and their sum is 8, so that means this is 4, and this is 4. So that means if we move that part, then this part, there's going to be 4 more on this side, so that means the whole thing is going to be 12, right? Since this side is 12, that means this side is also going to be 12, right? So this is 12. And so for this to be 12, and the whole thing is 18, so that means y must be equal to 18 minus 12, which is 6, right? So y equals 6, it's A. Number 7, Mary is 20% older than Sally, and Sally is 40% younger than Danielle. The sum of their ages is 23.2 years. How old will Mary be on her next birthday? Okay, so since we are dealing with percentages, this is kind of unrealistic, but let's say that Danielle is 100 years old, right? Then Sally would be 40% younger, so Sally would be 60 years old. And then Mary is 20% older than Sally, so this is 60 times 6 over 5. So this is going to be 72, right? So Mary's going to be 72 years old, and Sally's going to be 60 years old, and Danielle's going to be 100 years old, right? And so if we sum their ages, that's going to be 232, right? But then this number, we saw it kind of before. It's the sum of their ages is 23.2 years, right? So that means we've got a decimal point right here, and so that also means that we've got a decimal point on right there for Mary, Sally, and Danielle's ages. Okay, so that means Mary is 7.2 years old, because little kids care about like 0.2 ages, and Sally is 6 years old, and Danielle is 10 years old, right? So how old will Mary be on her next birthday? So since she is 7.2 years old now, on her next birthday she will be 8 years old, so that's the answer, it's B. Number 8, how many sets of 2 or more consecutive positive integers have a sum of 15? So since 15, since this is a odd number, there can be two numbers. So it can be expressed as the sum of two numbers, which is namely 7 and 8. And then 3, that's possible because 15 is because 15 is a multiple of 3, so that's 4, 5, 6, right? And the 4, it's not possible because 15 isn't a multiple of 4. And the 5 is possible because it becomes 1, 2, 3, 4, 5. And then now, since this has the first number of 1, this is 1, that means that this is the limit. Because they all have to be positive integers, so any more will go to the negative numbers. So these are going to be limits. This is the 3 sets, right? So 3 sets. So 3 is the answer. It's C. Number 9, Oscar buys 13 pencils and 3 erasers for $1. A pencil costs more than an eraser, and both items cost a whole number of cents. What is the total cost in cents of one pencil and one eraser? Okay, so let's say the pencil costs P cents and the eraser costs E cents. That means 13P plus 3E equals 100 cents. And then it just said that both items cost a whole number of cents. So we just have to do a little casework here because we just have to figure out integer values of P and E. So if we do that, we will see that pencil equals 7, right? P equals 7, and then that will give us E equals 3, right? So the total cost in cents of one pencil and one eraser, that's going to be 7 plus 3, which is 10, right? So 10 is the answer. It's A. Number 10, for how many real values of x is this an integer? Okay, for that to be an integer, then the number within the square root, that has to be a perfect square, right? And so since 120, this is between 10 squared and 11 squared, right? That means 120 minus root of x can be maximum 10 squared. So it can be all the way from 0 squared, 1 squared, 2 squared, all the way to 10 squared, right? And that's because root x has to be a positive value, right? Because it's the real values of x. So we have 11 possible choices. 11 choices. So 11 is our answer. It's E. Number 11, which of the following describes the graph of the equation this? Okay, so so if we expand that, that's going to be x squared plus 2xy plus y squared equals x squared plus y squared. So x squared cancel, y squared cancel. So that gives us 2xy equals 0. That gives us xy equals 0. That means either x equals 0 or y equals 0, right? And so if we have a coordinate plane, then it's going to be either this line, y equals 0, this is y equals 0, or this line, which is x equals 0, right? So that's just two lines. The answer is C. Number 12, a number of linked rings, each 1 centimeter thick, are hanging on a peg. The top ring has an outside diameter of 20 centimeters. The outside diameter of each of the outer rings is 1 centimeter less than that of the ring above it. The bottom ring has an outside diameter of 3 centimeters. What is the distance in centimeters from the top ring to the bottom of the bottom ring? Yeah, so if we draw one of these rings, then that's going to look like this, right? And then since this is each 1 centimeter thick, that means these are going to be 1 centimeter in length, right? So this is also going to be 1 centimeter. And so it said that the top ring has an outside diameter of 20 centimeters. And what outside diameter means is that from here to here, this much is 20 centimeters, right? And so that means if we subtract 1 and 1, that means the inside diameter would be 18 centimeters, right? So this would have an inside diameter of 18 centimeters. Since the rings are linked and they're hanging on a peg, so that means that if you look closer, then yeah, so it's kind of blurry, but this much and this much, they are overlapping, right? So they are going to overlap when you count the outside diameter, right? Because the outside diameter ranges all the way from like here up to there, and then from from here to down, right? So it's going to be overlapping, right? But then if we just look at the inside diameter, right, then the inside diameter of the first ring, that's just going to be just this much, right? So this is going to be the inner diameter. For the one below that, this is going to be the inner circle, right? Something like that. If you see, they don't have an overlap at all, right? They just touch at the diameter, right? So they just touch where they meet. And so for convenience, we're just going to focus on the inner diameter. So the top ring has an inner diameter of 18 centimeters, and so has the 1 centimeter less, right? Because the outside diameter has 1 centimeter less. To get the inside diameter, so let's just write a formula. Inside diameter. This is equal to outside diameter minus 2, right? So since this whole thing is 20, the inside is that minus 2, and for the next one, the outside is 19, so the inside is going to be that minus 2, which is 17 centimeters, right? So 17 centimeters, and then the next one, that's going to be one less than that, so that's going to be 16 centimeters, right? All the way to the bottom ring, which it says has an outside diameter of 3 centimeters, right? So since the outside diameter is 3, that means the inside diameter is 1, right? And so that means this inside diameter, that length, so the length from here to here, so this much, that's going to be 1, right? So this is going to be exactly 1. And so we want the total distance, right? So for the total distance, we can just add up the inner diameter because they are not overlapping, they're just touching, right? So they're just touching right here. This one's the upper one, this one's the lower one. And so to get the whole thing, we can just add all of the inner diameters plus 2, right? And this plus 2 is because we also have the outer diameter of this one and the outer diameter of this one, right? And that is that is included in the distance from the top of the top ring to the bottom of the bottom ring. And so if we do this now, this is going to be 1 plus 2 plus 3 plus all the way to 18, and then we're going to have 1 plus 2 over, right? 1 plus 2. So this is going to be all over 2, and then 18 plus 9, sorry, 18 times 19 plus 2. So this is going to be 171. Yeah, so this is going to be 171 plus 2, right? So it's 173. So 173 is the right answer. It's B. Number 13, the vertices of a 3 by 4 by 5 right triangle are the centers of 3 mutually externally tangent circles as shown. What is the sum of the areas of the 3 circles? Right, so this is 3, this is 4, this is 5, and let's say that this much is A, right? So the radius of that's A, the radius of the B is B, and the radius of C is C, right? So that will give us A plus B equals C, B plus C equals 5 because of this one, and A plus C equals 4. Right, sorry, not A plus B equals C, A plus B equals 3, right? So this would give us that A equals 1, B equals 2, and C equals 3, right? And then you can just look and check. So this is 1, this is 2, that gives us a sum of 3. This is 3, sorry, that's 2 and 3, that gives us 5. This is 1 and 3, that gives us 4. And so the sum of the areas of the 3 circles, C is equal to 3, right? So the sum of the areas, that's just going to be 1 squared pi plus 2 squared pi plus 3 squared pi. This is equal to pi times 1 plus 4 plus 9 equals 14 pi, right? So 14 pi is the answer, it's E. Number 14, 2 farmers agree that pigs are worth $300 and that goats are worth $210. When one farmer owes the other money, he pays the debt in pigs or goats with change received in the form of goats or pigs as necessary. For example, a $390 debt could be paid with 2 pigs with 1 goat received in change. What is the amount of the smallest positive debts that can be resolved in this way? Okay, so first of all, $200 debt, that is obviously possible since somebody can just give the other 1 goat, right? And the $90 debt is also possible because somebody can just give $300 and then take $200 in return. And then for 30, this is also possible because this is 210 times 3, right? So 3 goats give 3 goats and then get 2 pigs back, right? So this is going to be 30. Right, so 30 is also possible, but then from $10 this is not possible, right? And that is because 300 and 210, they are multiples of 30, and that means that debt can be resolved. Debt of multiples of 30 only can be resolved, right? Is okay, right? And so since 10 and 5 they are not multiples of 30, then they cannot be resolved, right? So B and A, these are just gone. So this is possible. So C is the smallest possible debt. The answer is C. Number 15, suppose the cosine of x equals 0 and the cosine of x plus z equals 1/2. What is the smallest possible positive value of z? Okay, so let's draw a cosine graph. So this is what I've brought out. So this will be our cosine graph, right? So this is going to be cosine theta. Sorry, this is cosine x, right? This is x and this is y, like that. Cosine x equals 0 and then cosine x plus z equals 1/2, right? So for cosine x plus z equal to 1/2, this must be 1/2, and then this will be the x plus z, and then this point will be x, right? And then so if we put that down here, then this much is going to be, so this distance is going to be z, this is going to be z, and so we want the smallest possible positive value of z. And then if we look here, that's going to be, x is going to be 3 pi, so that's going to be 3 over 2 pi, right? And then this value, when cosine x equals 1/2, that's going to be, so x plus z, this is going to be 5 over 3 pi, right? And so to get z, we just have to subtract. So subtract this from that. So that's going to be 5 over 3 minus 3 over 2. This is going to be equal to 1 over 6, right? So this times pi, so this is 1 over 6 pi. So this is our answer, it's A. Number 16, circles with centers A and B have radii 3 and 8 respectively. A common internal tangent intersects these circles at C and D respectively. Lines AB and CD intersect at E and AE equals 5. What is CD? Okay, so they have radii 3 and 8. So this one has 3, and DB, this one has a radius of 8, right? And so now we can just draw some more lines, right, from AC, and then going all the way like that. And then from B, going parallel to CD like that, right? And so that means this is going to also be 8, and we want this length because that's the equal as CD, right? Because these and these are the same, right? And then since we know that AE equals 5, right? So that's going to give us that this much equals 5, that equals 5. And since this is a right triangle, then that means that this ACE triangle, that's a 3 to 4 to 5 triangle. So that means it's going to be 3 to 4 to 5. And so that means CE equals 4, right? And so CE equals 4, and then we want CD, which is equal to this much, right? And so now we can use the fact that ACE and this large new triangle, they are similar triangles, right? And so since this ratio is 3 to 4, this to this ratio, that's also going to be 3 to 4, right? And so if we say that this is x, right, then 3 to 4, which is this ratio to that ratio, this is going to be equal to 11 to x, right? Because this whole thing is going to be 3 plus 8, which is 11, right? And so if we cross multiply, that's going to give us 44 equals 3x, right? And so x is going to be equal to 44 over 3, right? So if we write that again, x is going to be equal to 44 over 3. So the answer is B. Number 17, square ABCD has side length S. A circle centered at E has radius R, and R and S, they are both rational. The circle passes through D, and D lies on BE. Point F lies on the circle on the same side of BE as A. Segment AF is tangent to the circle, and AF equals root 9 plus 5 root 2. What is R over S? Okay, so if we draw some more lines, right, then we're going to have a line from B stretching all the way to E, like that. And then we're going to have a line from F to E, like that. And then if we draw a line from A to E, and A to D, and then stretching further, and then from E down right there, like that, okay? And so since the circle has radius R, that means this is R. So this is R, and so this is R, and this much is also R, right? Let's write that in orange. This is R. And since this is a square, and this is a diagonal of the square, that means this is 45 degrees, right? And so since this much is 45 degrees, that means this is also 45 degrees. So this is 45 degrees, and this is a right angle. That means this is so that means that's a right isosceles triangle, right? That's an isosceles right triangle. That means this and this are the same, and the ratio of the length is 1 to 1 to root 2, right? So since R times, so the ratio of this times this is root 2 to 1. That means this much, that is R over root 2, right? And the same thing over here, this is also R over root 2, right? And then since ABCD has side length S, that means this is S, and that also means that this is also S, right? This is also S. And then point F lies on the circle, and on the same side of BE as A, and the AF is tangent to the circle, right? And then we know that that's root 9 plus 5 root 2, right? So that means this length, this is root 9 plus 5 root 2. And so now we can look at these two triangles, this one and this one, right? They are both right triangles, and they share that length, right? And so we can see this triangle versus this triangle. And so that means AE square is going to be equal to AF square, sorry, that's going to be equal to AF square plus FE square, which is also going to be equal to, let's say this point is, I don't know, P, right? That's going to be equal to AP square plus EP square, right? And so this much is because of the green circle, and this is because of the orange circle. If we just get all of these out, then AF squared plus FE squared is going to be 9 plus 5 root 2 plus FE squared is R squared, right? R squared, and this is going to be equal to AP squared plus EP squared, so this is S plus R over root 2 squared plus root 2 over R over root 2 squared. And so if we expand that side, that's going to be R squared over 2 plus R squared over 2 plus S squared plus plus root 2 RS, right? And so we know that this is R squared and that is R squared, so those two can be cancelled. This and these two, they can be cancelled. And since we know that this and this should be the same, and this and this and that should be the same, that means 9 equals S squared, 9 equals S squared, and 5 equals RS, right? So since 9 equals S squared and S is a positive number, that means S equals 3. S equals 3, and since 5 equals RS, R is going to equal 5 over 3, and so R over S, this is going to be 5 over 3 over 3, this is going to be 5 over 9, right? So this is 5 over 9, it's B. Number 18, the function f has the property that for each real number x in its domain, 1 over x is also in its domain, and this is true. What is the largest set of real numbers that can be in the domain of f? First, let's look at just this one. So fx equals f1 over x equals x. But then what if we replace x with 1 over x, right? Because if x is in it, then 1 over x is also in it. So that's going to be, this is going to be f1 over x plus f1 over 1 over x, and that's just x, right? So this is just x is equal to 1 over x, right? Oh, but then you see these, that and this is the same. That means this and this should also be the same. That means x equals 1 over x, right? That should mean x squared equals 1. That means x can be negative 1 and 1 only. So the largest set of real numbers that can be in the domain of f, that's just these two. That's E. Number 19. Circles with centers 2, 4 and 14, 9 have radii 4 and 9 respectively. The equation of a common external tangent to the circles can be written in the form y equals mx plus b with m is greater than 0. What is b? If we first make some lines here, then that's just all going to be something like this. I've just done it all together. And then we know this line, so that length, right? Because this x is 14 and this x is 2, that means this length is going to be equal to 12. So this is 12. I'll write that in blue. This is 12. And for the same reason, this much is 9 and this much is 4 by 4, right? That means this is equal to 9 minus 4, and that is 5, right? So if we draw a line like that, right? So a line like that. So this line is going to be y equals 5 over 12x, right? Because the slope is going to be 5 over 12, and then it's crossing 2, 4, right? So 5 over 12 times x minus 2 plus 4. So this is going to be 5 over 12x, right? No. Actually, let's try to find this point, right? The point where it intersects with x, right? Because this line, that's also going to intersect this point, so we can use that to figure out the actual line of that later. So if we do that, then this is going to be when y is equal to 0, right? So when y is equal to 0, then that's going to be 0 equals 5 over 12 x minus 2 plus 4. And so 5 times x minus 2, and then plus 4 times 12, which is plus 48. That over 12, this is going to be 5x plus 38 over 12. And so that's going to mean that x is equal to negative 38 over 5, right? So x is negative 38 over 5. So this is negative 38 over 5, 0, right? So that's all that it can give us. And next, let's look at this angle, right? That angle is, let's say that angle is theta. And so that would be tangent theta. Tangent theta, this is going to be the slope of this, which is 5 over 12, right? 5 over 12. since this line, so that that has the same slope as that orange line, right? So both orange lines have the same slope, but then you can see this angle, that is 2 times theta, right? Because this angle is also theta, so this is going to be 2 theta. And so we want to get tangent of 2 theta, right? Tangent of 2 theta, and this is just tangent theta plus theta, and so this is going to be tangent theta times 2, so 2 tangent theta over 1 minus tangent square of theta, right? So that's going to be 2 times 5 over 12, 2 times 5 over 12, 5 over 12, over 1 minus this squared, which is 25 over 144, right? And so this is going to be equal to 5 over 6 over 144 minus 25, which is 119 over 144, right? So this is 119 times 6 over 5 times 144. And so this is going to be equal to, so that's going to be equal to 5 times 144 and times 6. That's going to cancel out. That's going to give us 120, right? So this is going to be the slope of this line, and that slope is equal to the slope of this line, which we want to get, right? And so this is going to be y equals, and then the slope is 120 over 119, right? So we can get rid of this one. So y equals 120 over 119 times x. And then we solved before that. It goes through that line, so at that point, which is negative 38 over 5 comma 0, right? So it's times x plus 38 over 5, right? And so this is going to be equal to 120 over 119x, and then we have to multiply these two. So if we do that, then that's going to be plus 119, plus all over 119, and then 120, and then it's going to be 120 divided by 5, so that should be, what is it, 24, and then times 38, and then 24 times 38, that's going to be 912, so this is 912 over 119. This is our y-axis. Sorry, that's our y-intercept. And b is what we want, and b is the y-intercept, so we've got what we want. So this is the answer. It's E. Number 20. A bug starts at one vertex of a cube and it moves along the edges of the cube according to the following rule. At each vertex, the bug will choose to travel along one of the 3 edges emanating from that vertex. Each edge has equal probability of being chosen, and all choices are independent. What is the probability that after 7 moves, the bug will have visited every vertex exactly once? Okay, so let's draw a cube right here, like that, and then, we will have lines like that, dotted lines. This is going to be the back, right? So let's say that the bug starts at this end of the cube because it doesn't really matter where we start, like that, right? Yeah, so let's just get our total number of choices. That is going to be 3 to the 7th power, right? Because this 3 is because at every vertex there is 3 ways to choose, right? So there's 3 ways that it can go, and then the 7 is because this is after 7 moves, right? So 7 moves are being passed, so that's why it's 7. And then now we just have to find the possibilities where all vertices are crossed once, right? So first we're going to have 3 possibilities, right? 3 possibilities, and it can go either here, here, or here. Let's just say that we chose this one, right? So that one, we multiply it by, and then from this one, where can we choose to go, right? No matter where you choose to go, that's just all going to be the same, right? So it's going to have just made a straight and then a turn, and then a 90-degree angle turn from the first point. So it doesn't really matter, right? So we have 2 choices since it can't go back. So 3 times 2, so that's either this way or this way. And let's say that we chose, this way, right? So we are here now, and we want to look at the number of ways that we can go everywhere. So we can go to all 7 vertices and then and then just stay there, right? And so if we just draw that out, we are going to have one being this one from here to like that, and there, and there, and there, like that. And so that will give us having visited every vertex like that. Yeah, so that's one. Or we could have gone up like that, and then we could have gone like that, right? So that's one more. And then lastly, we could have just gone like this and then gone up, right? And then come down like that. So that's 3 ways. And then there are no other ways, right? So that's just times 3. That's just times 3. And so this is going to be equal to 18, right? And so it's going to be 18, which is the total number of possibilities, over the total choices, which is 3 to the 7th power. And so this is going to be, if we divide by 9, this is 2 over 3 to the 5th power, and 3 to the 5th power, that's 243, right? And so 2 over 243, and that's it. So that's going to be our answer. It's C. Number 21, let S1 equal this and S2 equal this. What is the ratio of the area of S2 to the area of S1? Okay, so S1 and S2, they are both shapes. And first of all, let's look at this one. Yeah, let's just do that in black. From this, we can know that, so since this one is just going to be log 10 of 10, right? And then log something plus log the same base of something, that's just going to be the same thing, right? So, so that's going to be just then multiplied. So this is going to be equal to log 10 of 10x plus 10y, right? And so since these both have log 10, right? So since these are the same, that means this and this, they are going to be the same, right, with this. And so that's going to be 1 plus x squared plus y squared. This is less than or equal to 10x plus 10y, right? And that's going to be x squared minus 10x plus y squared minus 10y. This is going to be less than or equal to -1. And so if we perfect square these, so that's going to be x minus 5 squared plus y minus 5 squared. This is going to be less than or equal to 50 minus 1, right? 50 minus 1, that's 49. This is 49. And so from here, we can see that the radius of the circle squared equals 49. And that's because if we look at this one, that's just a circle that is centered at 5,5, right? So that's just a circle that's centered at 5,5, and so that's going to be the circle, and this is going to tell us the square of the radii. So this times this, that's going to be 49, right? So that's the area of the shape we want to get. Yeah, and for this next one, let's do it in blue. Same thing as with this one. So this is going to be 2, which is log 10 of 100, right? And so if we just add those two, that's going to be log 10 of 100x plus 100y. And so this is log 10 of 2 plus x squared plus y squared, and then of that. So that's going to be 2 plus x squared plus y squared is less than or equal to 100x plus 100y. And so x squared minus 100x, x squared minus 100x, plus y squared minus 100y, this is going to be less than or equal to -2. And so if we perfect square these like we did before, we're going to get x minus 50 squared plus y minus 50 squared. This is going to be less than or equal to 50 squared plus 50 squared, which is 5,000 minus 2. And that's going to be 4,998, and same thing as before. This is going, so this is going to be the radius squared, which is 4,998, right? So the radius squared is going to be 4,998, and that's because this is going to be also a circle, right? But then this time it's going to be centered on 50, 50, right? And so this is going to be the circle, and so this radius times that radius, that's going to be 4,998. That's what it means, right? And then lastly, it said it wanted the ratio of the area of S2 to the area of S1, right? And then the area of S2, this is 4,998 pi, because the radius squared is 4,998, and then we just have to multiply pi to that. And then the area of S1, this is just 49 pi, same thing. And so we want the ratio of those, so that will be 4,998 pi over 49 pi, and so these pi's cancel. This is 49, if you see, this is 49 times 98, I'm sorry, that's 49 and 98, so this gives us 100, and this gives us 2, right? So this is going to be equal to 102, so that's the answer, it's E. Number 22, a circle of radius r is concentric with and outside a regular hexagon of side length 2. The probability that 3 entire sides of a hexagon are visible from a randomly chosen point on the circle is 1/2. What is r? Okay, so first let's give a drawing of this, of a diagram. So this is going to be our diagram. This is going to be our circle. Sorry, that's going to be our regular hexagon. So this is going to have side length 2, and this is going to be our circle. And then we want the so we want 3 entire sides of hexagon visible from a randomly chosen point. So that to be 1/2. And if you see here, since this is the hexagon, so the only points on this circle where 3 entire sides are visible, that is within these gaps, because within right here, then people will just be able to see just these 2 sides, but from here we can see this side, and this side, right? So so 3 sides are visible, and so we want this distance to be equal to that distance, right? Because since we have 6 of those same distances like that, and then 6 of the just seeing 2 distances like that. And so since this one and this one has to be the same, right, that means if we draw lines, so this distance and that distance has to be the same. And so now let's look at the numbers. Their side length is 2, that means this much is 2. And then if we have the center of the circle like that, so if we just get the center of the circle, if we just draw lines, then this is going to be our center, and this length, that's going to be 2. And since this is 2 and this is 2, right, that's 2, and this is also 2, so since this is 2 and this is 2, that means the whole thing, that's going to be 4, right? So this is 4, that's 4, and so this triangle, that is going to be that's going to be a 30, 60, 90 triangle. So this is 2 to 1 to root 3. That means this length, that will be 2 root 3, right? 2 root 3. And since we can see that here from here to there, so this triangle, that triangle is going to be the same triangle as this triangle, right? So this length is also going to be 2 root 3. And so since these two are so since they have the same length, this is also going to be 2 root 3. That's 2 root 3. So that means this is also going to be 2 root 3. 2 root 3. We have a lot of 2 root 3's here. And since we can see that that's an equilateral triangle, so this is 60 degrees, that means this is 60 degrees, and since those two are the same, that means this is also an equilateral triangle. That means this length is also 2 root 3, so let's write that. This length is also 2 root 3, and then we want the radius r. And so if we draw a line from the center to this point, then that would be the radius. So this is the radius. We also know that this is 2 root 3. Let's just write that again in red. This is 2 root 3, and this is also 2 root 3. That means this is an isosceles triangle. Since if we draw a line from here to right there, we see that this is also going to be a right triangle. So this is a right angle, and this is 60, and this is 30 degrees. And so that means that this angle, so this angle plus this angle, they are going to be the same as that angle, which is 30 degrees. That means this and this, they are going to be 15 degrees each, right? So let's write that in, let's say light blue. So this is going to be 15 degrees, and this is also going to be 15 degrees. And so if we draw a line from that midpoint to right there, so that it makes a right angle, that means that triangle will be a right triangle with it having 15-degree angle, right? And so let's just make that a little larger. So that will be something like this, and then this will be 15 degrees. This is the center, and then this is half of the radius. This is half of the radius, and this is 2 root 3, 2 root 3, right? And so since we have this and this, right? And since we have this 15 degrees and this 2 root 3, that means 1/2 of r is going to be 2 root 3 times cosine of 15 degrees, right? So that means 1 whole r, that's going to be 2 times 2 root 3 times cosine of 15, which is 4 root 3 times cosine of 15. So this is 4 root 3 times cosine of 15, which is root 6 plus root 2 over 4. So these two cancel. This is going to be 3 root 2 plus root 6, right? So that's 3 root 2 plus root 6. So this is our answer, which is D. Number 23. Given a finite sequence S equals this of n real numbers, let AS be the sequence this of n minus 1 real numbers. Define A1S equals AS, and for each integer m between 2 and m minus 1, define AMS equals A times A of AM minus 1S. And suppose x is greater than 0, and this is true. If A100S equals 1 over 2 to the 50th power, then what is x? Okay, so let's just start by writing a n's of x, right? So a1s, this is going to be equal to, it's just this, right? S is going to be from 1x all the way to x to the 100th power. So that's going to be x plus 1 over 2. And x times x plus 1 over 2, right? Because x plus 1 over 2, because it's x squared plus x, right? And then it's also going to be x cubed plus x squared. So that's going to be x squared times x plus 1 over 2, all the way up to x to the 99th power x plus 1 over 2. And then the next is a squared, is a2 of s, and this time it's going to be a of a m minus 1s. So this is all over 2 squared, and then x plus 1 squared, right? It's x plus 1 squared. And also it's going to be x times x plus 1 squared over 2 squared, and x squared times x plus 1 cubed, squared, 2 squared, and then all the way up to x to the 99th power times x plus 1 squared over 2 squared. And so as this continues, we see that this number is equal to this number, as well as this number, and this, and the numbers and the things in front, they just stay the same, right? And so what that gives us is what an can be, right? So that gives us that an of s is going to be equal to x plus 1 to the nth power over 2 to the nth power, and x plus 1 to the nth power over, x times x plus 1 to the nth power over 2 to the nth power, x squared, x plus 1 to the nth over 2 to the nth, all the way to x to the 99th power, x plus 1 to the nth over 2 to the nth. 2 to the nth. And so since it's going to be equal to 1 over 2 to the 50th power, then that means we can just take that one and set that as equal to 1 over 250, and that's when n is 100, right? And so that's going to give us 100 of s. This is going to be equal to, so that's going to be equal to x plus 1 to the 100th power over 2 to the 100th power. This is equal to 1 over 2 to the 50th power. So x plus 1, so x plus 1 to the 100th power, this is equal to 2 to the 50th power. That means x plus 1 equals root 2. So x equals root 2 minus 1, right? So x equals root 2 minus 1. This is the answer. It's B. Number 24. The expression that is simplified by expanding it and combining like terms. How many terms are in the simplified expression? Okay, so since we see that x is just still positive, but y and z, they become negative, and so let's say that x is just equal to a, and let's set y plus z equal to b. So then this will be, so then it's going to become, let's write it down there, x, that's going to be a plus b to the 2006 power plus a minus b to the 2006 power. And then we can see that the terms that don't cancel, so not cancel, those are going to be even powers, right? Even powers, and that's going to be a to the 2006 power. Sorry, that's going to be a to the 2006 power, and a to the 2004, b squared, a 2002, b fourth, a 2000, b to the 6th power, all the way up to just a 2, b 2004, and b to the 2006 power. And so if we look at the number of terms for a's and b's, right, this gives us that since a is just x, right, that means a to the nth power, this is just going to have one term, right? That's going to just be one term. B to the nth power, this is going to be y plus z to the nth power, so this means that there's going to be n plus 1 terms, right? So each of these, that's it. So that's going to be the multiple of the number of terms, right? So this is going to be 1. This is going to be 1 times n plus 1. And so since n is 2, it's going to be 3, right? So let's just write that down. So the number of terms, this is going to be equal to 1. And then plus we have 1 times 2 plus 1, which is 3, right? And then we have 1 times 4 plus 1, 5, and then 1 times 6 plus 1, which is 7, plus 9, plus 11, all the way up to 2007, right? And so this is, and so if you see, this is 1004 terms, so that's going to be 1004 squared, because sum of odd numbers is n squared, right? And so 1004 squared, if you see, that's just going to be 1008016, right? So this is the answer, it's D. Our last problem, number 25. How many non-empty subsets S of 1 to 3 all up to 15 have the following two properties? 1, that no two consecutive integers belong to S, and if S contains k elements, then S contains no number less than k. So the first thing that we have to notice is that the maximum of k, this is going to be 5, right? So the maximum value for k is going to 5. It is going to be 5 because if k is greater than 5, if k is greater than 5, then there will always be always be a consecutive number that is in the S, right? So if we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 14, and then 15. If k is 6, then we can only have values from there, and we have to choose 6 values. So we have 1, 2, 3, 4, 5, and then our 6th value has to be a consecutive number, right? So that means the maximum value of k equals 5, and since k is maximum value, that's a low number, then we can just do casework by setting k values. So if k is equal to 1, that means that we can just have everything, and then just choose 1 from there. So that's 15, choose 1, which is 15. And then if k equals 2, that means that we have 13 k's left to choose from here, 13 numbers left to choose from, since we can't choose 1 or 2, and that's going to be 13 choose 2, right? Because we have to choose 2 from there since k equals 2. So this is going to be 13 choose 2, which is 78. And when k equals 3, we're going to have 11 numbers left, and out of them we're going to have to choose 3, so that's 11 choose 3, right? So that is 165. And if k equals 4, we are going to have 11 minus 2, right? Because we see the pattern, it's odd numbers and it's decreasing. So that's just 9 choose, and the k is 4, so it's 9 choose 4. This gives us 126. And lastly, for k equals 5, this is just all the way minus 2, so that's 7 choose 5. This is 7 choose 2, which is 21, right? And so if we just add these numbers all up, then that's going to give us 15 plus 78 plus 165 plus 126 plus 21, which is equal to 405. So this is going to be our answer. It's E. And so that was it for the AMC 12A from the year 2006, and thank you for watching.